You can ask an AI to write a poem about a lost sock in the style of Shakespeare, and it'll do it. You can ask it to debug a tricky piece of code, and honestly, it's pretty good at it. But the second you ask it a super simple question like, hey, what's the weather like outside right now? It just hits a wall. And that wall, that single limitation, is what's been keeping AI from being truly useful in our day-to-day lives.
And that quote really just nails it, doesn't it? Large language models, or LLMs, they are incredible conversationalists. But there's this massive gap between how well they can talk and how connected they are to the real, live, ever-changing world. They're amazing at talking about things, but they're not so great at actually knowing things.
So here's a way to think about it. Imagine an LLM is this brilliant analyst. I mean, someone who has read literally every book, every article, every web page up until last year. But here's the catch. They're locked in a room, no internet, no phone, no access to your company's systems. Just them and the books they've already read.
Okay, so you go up to the door of the room and you ask our analyst, what's the weather in Berlin right now? What can they possibly say? Well, they might remember reading that Berlin is usually chilly in October, but they can't tell you the actual temperature. They have no window. Their knowledge is completely frozen in time.
Or what about this one? How many users signed up today? I mean, that information isn't in any book. It's tucked away inside a private company database. Our analyst has absolutely zero way to get to it. They're completely cut off from any private, real-time data.
So let's just quickly recap these core problems. First, their knowledge is static. It's stuck in the past. Second, if they don't know something, they'll often hallucinate, which is just a fancy way of saying they'll make a very confident-sounding guess. Third, they have no access to private systems. And finally, and this one's a little weird, you can't always trust them to do basic math correctly. And when you're trying to build something serious, probably correct just doesn't cut it, right?
And this is where you see the huge difference. A standalone LLM, it guesses. It's stuck in the past. It's totally isolated. But an LLM with tools, it can verify facts, it has access to live data, it's connected to the world. So the big question is, how do we get from the one on the left to the one on the right?
Well, we give our smart analyst a set of keys. And these keys are a concept we call tool calling. It's the bridge that finally connects the model's incredible brain to all the resources of the outside world. This is how we finally unlock that door.
So what is tool calling really? It's the model's ability to recognize, hey, I can't answer this just from what I know, and instead of making something up, it pauses. It figures out it needs help from an outside tool like a weather API or a database, and then it uses the real data it gets back to give you an answer based on actual evidence.
Okay, let's break this down because this three-step pattern is absolutely crucial. First, the LLM decides. It sees your question about the weather, realizes it needs a tool, and creates a perfectly structured request, kind of like filling out a work order. Step 2, a system we call the harness executes. The harness is the one that actually safely goes and calls that weather API. Then finally, step 3, the LLM explains. The raw data comes back from the tool, and the LLM translates it into a nice, friendly, human-readable sentence for you.
So what kinds of tools can we actually give to our newly connected analyst? Well, the possibilities are pretty much endless, but they tend to fall into a few really important categories.
We can give it web search so it knows what's happening in the world right now. We can connect it to a database for specific company data. We can give it a calculator for math it can't mess up. We can even give it the ability to run code for complex tasks or to access your email and calendar to actually help you manage your day.
Let's just take database lookup for a second. If you ask, hey, how many payments failed today? The model doesn't just guess a number. Instead, it generates a perfect little SQL query, hands it off to the harness to run against the database, gets the real number back, and then reports the fact to you. It completely shifts from guessing to knowing.
And what about the calculator? Now, this might sound almost too simple, but here's the wild part. LLMs can actually be kind of bad at precise math. So instead of risking an error on your quarterly report, the model is smart enough to just say, hey, I'm going to offload this calculation to a tool that is guaranteed to be right 100% of the time. It's all about reliability.
Now this is where it gets really, really cool. Let's see how it all comes together. You ask it to schedule a meeting. It doesn't just do one thing. It chains multiple tools together in a sequence. First, it uses the calendar tool to search for open slots. Then, it uses the calendar tool again to create the event. After that, it uses the email tool to draft and send the invite. The LLM becomes the conductor of an orchestra of tools, transforming from a simple chatbot into a powerful assistant.
Of course, giving an AI the keys to all these powerful systems, well, that comes with a whole lot of responsibility. You can't just hand over the keys to the kingdom without any rules. You have to build a secure framework around it, a safety harness, to make sure it uses these new powers safely.
And what's so smart about this setup is the clear separation of jobs. The LLM is the brain. Its job is to figure out what needs to happen. But the harness, that's the hands. Its job is to figure out how to actually do it safely. You're separating the creative, sometimes unpredictable part of the AI from the secure, deterministic part that takes action.
You can think of the harness as the AI's secure operating system. It's the gatekeeper that's going to stop the model from running a dangerous command. It's the privacy shield that prevents it from leaking sensitive data. And it's the supervisor that makes sure it respects who is allowed to do what. It's the essential guardrail that makes all of this incredible power safe enough to actually use.
So let's just zoom out for a second and look at the big picture. This shift from a standalone model that just talks to an integrated system that uses tools, it's a fundamental change in what AI is and what it can do for us.
And if you only remember one thing from this whole explainer, let it be this. It's this beautiful, powerful partnership. The model provides the reasoning, the what if, but it's the harness, working with the tools, that provides the reality, the what is. And really, one is pretty much useless without the other.
And you can see that transformation right here. The AI stops being a brain in a box that just pretends to know things. It becomes an agent that can actually be a researcher or an analyst or your personal assistant. It stops just talking and it starts doing.
And that really is the future of truly capable AI. It's not just a race to build bigger and bigger models. The smartest, most useful AI systems are going to be the ones that have the best, most reliable, and most secure connection between their powerful reasoning engine and the real world.
Which brings us to the final and I think most exciting thought. When an AI can safely use pretty much any digital tool you can give it, from searching the web to managing your entire project workflow, it just opens up a whole universe of new possibilities. So the question isn't just what can AI say anymore? The real question is, what problem are you going to solve with it first?